One of my main goals for this chapter is to make sure that you understand the meaning of certain terms you hear people use when they're talking about numerical data. And the first term we're going to use is what's called measures of center or measures of central tendency. When people talk about those, they're talking about numbers that are used to describe a typical data value of a set. And there's three that are commonly used. And the first one we're going to look at is what's called the mean of a data set. Now, the mean of a data set is the average. So most of you are familiar with how to find an average. You add up the data values and then divide by the number of data values. So for example, if we have the set of numbers 1, 2, 9, 8, 1, and the problem asks us to find the mean. First, we add them all up and we get 21. And then because there's 5 data values in that set, we would do 21 divided by 5, and we would get that the mean of that set is 4.2. So mean is just another word for average. I just put that here in parentheses. The next one that is used a lot in statistical studies that I really want to make sure you understand is what's called the median. The median of a data set is the middle number of a set. You might hear the term median used when you're talking about a strip of land that goes down the middle of a road. That's the median of the road. Median is the middle. But here's something that's very important. It's the middle number after the values are listed in order. Probably the most common mistake my students make in statistics is not listing the values in order when you're finding the median. You don't have to have them in order when you're finding the mean because, well, when you add them up, the order doesn't matter. But for median, the order absolutely matters. It actually doesn't matter if you list them smallest to largest or largest to smallest because the middle is going to be the same either way. So let's take a look at our first problem where we have that same data set we had before, 1, 2, 9, 8, 1, and we're supposed to find the median of that data set. So here we start by listing the values in order. So we would have 1, 1, 2, 8, 9. And here we can see that the one that's in the middle is 2. So 2 would be our median. But let's take a look at something important with our next one. Here it says, find the median of the data set where we have 1, 2, 7, 9, 8, 1. Now when we list them in order, we have 1, 1, 2, 7, 8, 9. Here we actually don't have one number in the middle. We've got 2 numbers in the middle, 2 and 7. When you have 2 numbers in the middle like that, to find the median, you take the average of those 2 numbers. So in this case, we would do 2 plus 7 divided by 2. We end up with a median for that group of 4.5. The other measure of center that we want to talk about that is used sometimes to describe typical data values is what's called the mode. The mode is the most common data value of the set. The data value that happens the most often, or to use a term we used in the previous section, it's the value with the highest frequency. Now, if no value happens more than once, then there is no mode. In other words, if the data values are all different, there's no mode. But if you have more than one value that happens with the greatest frequency, then you can have more than one mode. Whenever you're talking about mean, median, and mode for a set of numbers, there's always going to be one mean, there's always going to be one median, but there could be no mode, one mode, or more than one mode. So let's look at some examples. So our first group here says, find the mode of the data set 1, 2, 9, 8, 1. Here we can see that the number 1 happens more often than any of the other data values. So 1 is the mode. If we look at our next set, it says blue, red, red, blue, green. Here we've actually got 2 values that occur the most, which are blue and red. So blue and red would both be modes in that case. If we look at our last set here, 6.0, 6.1, 6.5, 6.4, here the data values are all different. And whenever your data values are all different, we would say that there is no mode, like that. So mean, median, and mode are all used to describe typical data values of a set. You would use the mean when you want to talk about the average. You would use the median when you want to talk about what's happening right in the middle of the set of data. And you would use the mode when you want to tell what the most common data value in a group is. Okay. Now let's take a look at another kind of problem we're going to have here. It says, an instructor of a finite math class at a small liberal arts college collects data on the age of her students. And the data are recorded in the following frequency distribution, where it says age 18 has a frequency of 12. So that means 12 students in her class were 18, 9 students in her class were 19, 5 students in her class were 20, 2 students in her class were 21, and 2 students in her class were 22. And what we want to do is find the mean, the median, and the mode age of her students. So let's actually do mode first. Mode is the easiest one. The mode age is going to be the age that has the highest frequency. We can see pretty clearly that the highest frequency is right there at 12. I'm going to need to move this over. I'm going to need that space in here in a moment. So the highest frequency is clearly there at age 18. So 18 is the mode. Notice it's not 12 that's the mode. The mode is the data value that happens the most often. 12 is not one of the ages of her students. Her ages are 18, 18, 18, 18, 18, 18, and so on, like that. So the mode is the age with the highest frequency, which in this case is 18. The next one that I want to look at is the median. So when we're finding the median, here we're trying to find the middle data value. To find the median, what helps us is to first find the total of all the frequencies. So if we add up those frequencies, let's see, 12 plus 9 is 21, plus 5 is 26, plus 2 is 28, plus 2 is 30. Here we've got a total of 30 students in the class. Okay. Now what we want to do is find the median, the middle data value. Now, you might remember from our previous example when we were looking at the median, when you have an odd number of data values, the median is the number that's right in the middle. If you have an even number of data values, you're going to end up with 2 data values in the middle, and you're going to have to take the average of those. Just as a little bit of a shortcut, if you have an odd number of data values, whoops, I can't spell. Data starts with D, not A. If you have an odd number of data values, then to figure out which one is your median, you take the number of data values, you divide it by 2, and then you add 0.5. And that tells you which data value to look up. So for example, here when there were 5 data values, if you do 5 divided by 2 plus 1, it's plus 0.5, not 0.1. You take the number of data values divided by 2 and plus 0.5, you end up with 3. So that tells us that our third data value is going to be the median. And in this case, we had that. We had 2. But if you've got an even number of data values, like we're going to have in this example, then it's a little bit different. Remember, when you have an even number of data values, you're going to take the average of two data values. So the first data value you're going to use is the number of data values divided by 2. Then the second one you're going to use is the number of data values divided by 2 plus 1. For example, let's look back at this problem when we had 6 data values and we were trying to find the median. If you take 6 divided by 2, you get 3. So we start with our third data value, which is 2. Then if you do 6 divided by 2 plus 1, we get 4. So you have your 4th data value, which is 7. You take the average of the third and fourth data values to find the mean in that case. So looking at our current example, where we had 30 data values, if we wanted to find the median, since we have an even number of data values, to figure out which data values we need, we do 30 divided by 2, and then we do 30 divided by 2 plus 1, which gives us 16. So what we need is to find the average of the 15th and the 16th data value. So let's take a look at this up here. Okay. Our first 12 data values are 18. Basically, when it says 18 has a frequency of 12, that means you would start with 18, 18, 18, 18, 18, 18, 18, 18, 18, 18, 18, 18. The first 12 data values are 18. Now, the next 9, which is data value number 13 up to data value number 21, those are all 19 years old. So that means that the 15th data value is 19, and the 16th data value is also 19. If we do 19 plus 19 divided by 2, we get that the median for this problem is 19. Like that. Okay. Now the next thing I want to do is talk about finding, the median. Hold on a second. Whoa. That didn't go where it was supposed to.
Yeah, Dad.
Hey, hush. Let me slide that over here and fix that. So 18 was the first 12 data values. 19 was the 13th to the 21st data value. What I want to do last, or one we didn't figure out yet, is the mean. Oh, that was supposed to be red. The mean, or the average data value. And when you're given a frequency distribution like this, the easiest way to find the mean is to add a third column where you take each value and you multiply by its frequency. So here, for example, we start with 18 times 12, and that gives us 216. Then 19 times 9, that gives us 171. 20 times 5 gives us 100. 21 times 2 gives us 42. 22 times 2 gives us 44. And then we add up that column, 216 plus 171 plus 100 plus 42 plus 44, and we have 573. And then to find the mean of your data set, you take the total of that column, which here is 573, and we divide it by the total frequency, which was 30. So in this case, we have 573 divided by 30, we get the average age of the students in her class was 19.1. So the mode was 18, the median was 19, the mean was 9.1. The last thing I want to do is talk about an example of what's called a weighted average. With a weighted average, the numbers have different percentages or different relative weights when you're comparing their values. This happens a lot, for example, when you're calculating a grade for a class in high school or college. Often you might have a paper that's worth 10%, a midterm exam that's worth 20%, a final exam that's worth 50%, and so on, where the percents will all add up to 100. And let's talk about here how you're going to find the average in that sort of a situation. So here it says a teacher designs her course so that the homework counts 20%, quizzes count 10%, the 3 midterm exams count 15% each. So we have one midterm exam that's 15%, another midterm exam that's 15%, and another midterm exam that's 15%. And then you have a final exam that counts 25%. And we're given here what a person's grades were, and we want to calculate the final average. Here it tells us Marissa's homework average was 92. And since that counts 20%, we would do 92 times 20%, which as a decimal is 0.2. Next, the quiz average is 81. And since that counts 10%, we multiply that times 0.1. Next, her midterm grades, which are each 15%, are 75, 88, and 92. So we would have 75 times 0.15 plus 88 times 0.15 plus 92 times 0.15. And then last, the final exam grade was 87, and that one has a weight of 25%, which as a decimal is 0.25. So now to find the weighted average, we just have to actually take the time to calculate this. So 92 times 0.2 plus 81 times 0.1 plus 75 times 0.15 plus 88 times 0.15 plus 92 times 0.15 plus 87 times 0.25. Here we end up with a final average in the class of 86.5.